In this video, I want to talk about transesterification and what its importance or utility is. So, used oil from fryers, used to make French fries or fried chicken or wonton or whatever, has this kind of structure. It's a triglyceride, and this is a component of animal fats or corn oil or things like that. And it's an ester, it's a triester created from glycerol and three fatty acids. Now, in the transesterification process to make biofuel, 3 equivalents of methanol are added along with an H plus catalyst, sulfuric acid or whatnot, and this can transform this molecule into 3 equivalents of biofuel that can be used in gasoline engines, things like this. Oil directly from the fryer can be placed into diesel engines with some success. So it depends on where you're burning this and how you're using this to power something. Okay. Now the transesterification process looks like this. You have an ester that contains one type of alcohol, and you're adding a different type of alcohol to this, and you're adding an acid catalyst like sulfuric acid or toluene sulfonic acid, and you're going to make a different ester with a different alcohol component. So of course this is going to be driven by Le Chatelier's principle. So if you add a large excess of this will drive the equilibrium to the right. How does this chemical reaction work? We have our ester, which is the ethyl ester, and in the first step of the curved arrow reaction mechanism, you want to protonate the oxygen of the carbonyl oxygen. This will create a very potent electrophile that has a positive charge. Methanol now as a neutral nucleophile can attack the carbonyl carbon, giving us, after chemical reaction, this molecule here. Now, remember again, the goal is to try to kick off this leaving group, right? Ethanol is the leaving group, but we can't do that in its form that we have now. We need to have some protonation, deprotonation events occur. So methanol or something in solution is going to allow us to do proton transfers. That's what product solvents can do. So we can deprotonate this guy here. And then we have lots of different oxygen atoms. But remember again, we want to kick off that ethanol, right? So we got to protonate this oxygen on the right. Now it's protonated, and protonated things make good leaving groups. So there it is, right? And generally speaking, you want to use your lone pairs. So here's some lone pairs, or here are some lone pairs. Either one is going to work. It'll just give you a different resonance structure. So that's the elimination step. And that gives us a protonated ester. And we lose, ethanol in that elimination step. And then what happens is some alcohol in solution can deprotonate, giving us the neutral reaction products. And so that's how overall the ethyl group gets exchanged for the methyl group. It's deceivingly simple, but that's a pad-ped type of mechanism again, okay? All right, so that's transesterification. So esterification reactions are reactions between alcohols and carboxylic acids, and you can also react esters with carboxylic acids directly, okay? So now what I want to do is talk about, well, let's stop this video here to keep the subject simple.